An alert fires, checkout is failing in production. So you pull up the logs. There are thousands a second from dozens of services, and none of them says why it broke. We use logs, metrics, and traces every day, and usually treat them same way, as different names for the same thing. Each answers a different question. Confusing them can make a 10-minute problem take hours. So today we'll look at which signal to use when and how they all fit together. First, which signal answers which question. Then how tracing works. Trace IDs, spans, one request followed across services. And last, what ties the three together. How a vague alarm becomes one exact line of code. These are three signals for observability. It means working out what's going on inside a system from what it shows on the surface. Logs, metrics, and traces. The easiest way to tell them apart is by the question each one answers. Metrics, is something wrong? Traces, where is it wrong? Logs, why is it wrong? It comes down to three words: what, where, and why. We'll look at each one separately, then see how they work together on our real failure. Let's start with logs. A log is a time-stamped record of one event. At 2:13 and 47 seconds, this happened. That's it. A diary entry for your program. There are two kinds of logs. The old way is plain text, a print statement. A person can read it, a machine can't search it. The new way is structured logging, the same event written as data, a JSON with named fields. Why bother? Because now you can search it. Every error from the payment service in the last 10 minutes. That's one quick search. In plain text, it can be hours with grip. What a log gives you is detail. When you need to know exactly what one request did, the error, the stack trace, the values, nothing beats a log. It's the most detailed signal you have. But that level of detail comes with two costs. First, volume. At scale, millions of lines, and storing and searching them is slow and expensive. Second, and the bigger problem, is that a single log line on its own doesn't tell you much. You see that service B failed. You don't see what called B, what happened just before, or whether B was even the cause. Each line is detailed, but it stands alone. So use logs when you know the event and you need the detail. But all that detail only helps if you know where to look. At 2 a.m., you don't have that yet. You only know that something, somewhere, is wrong. So what alerts you before you even know what's wrong? That's the second one. The opposite of a log. Unlike a log, which captures one detailed event, a metric is simply a number tracked over time. It doesn't tell you what happened. It tells you how many, how much, and how long across your entire system. Requests per second, error rate, memory, latency. Every metric is an aggregate, many events boiled down to one number. There are three kinds you'll commonly run into. A counter only goes up, total requests, total errors. A gauge goes up and down, memory in use, open connections, queue length. A histogram is a distribution, latency sorted into buckets, so you can ask for the P95 or P99 how slow it is for your slowest users. Metrics are cheap and fast. Because they're just numbers, you can aggregate them and discard old ones without losing much. A histogram over a billion requests is tiny. A billion log lines is not. That makes metrics the right tool for the two things logs handle poorly: dashboards and alerts.
Metrics are cheap enough to measure everything continuously, but aggregating throws the detail away. A metric can tell you the error rate jumped to 5%. It can't tell you which requests failed or whose or why. You gave up detail to keep it cheap. Metrics are good at telling you that something's wrong, but don't tell you why. One common mistake to avoid. Avoid putting high cardinality data like user IDs or request IDs in metric labels. Every unique value creates a new series, and the storage cost adds up fast. That detail belongs in logs and traces instead. So use metrics for dashboards, alerts, and trends. They tell you there's a fire, but never where it started. But logs and metrics share the same blind spot. Your system isn't one program anymore. One checkout request might go through the gateway, auth, cart, inventory, payment, and the database. 6 hops. Checkout breaks. Metrics say payment latency is up. That's the symptom. Payments logs show a timeout. But where is the time actually going? Was payment slow itself or waiting on something downstream? Payments logs only show what happened inside payment, and its metrics are no different. Both lost the request the moment it crossed into the next service. That's the gap. Logs and metrics see one service at a time. A request crosses many. To follow the request itself, you need a signal that goes with it, end to end. That's the third signal. A trace follows one request across every service it touches. It's the link logs and metrics don't have. When a request first arrives, at the gateway for example, it gets assigned a unique identifier called the trace ID. Think of it as a tracking number on a parcel. From that point on, the same ID travels with the request through every service and every hop. Each piece of work along that path is called a span. The gateway handling the request, a span. The call to auth, a span. The database query, a span. Each span records a few things: a name, a start time, how long it took, and a few tags like the HTTP status or the database query that ran. The spans link up. Each span has its own span ID and points to its parent. The first span is the root. When the cart service calls inventory, inventory span becomes a child of cart span. Do that for every call and you end up with a tree that shows the full shape of the request, who called whom and in what order. But how does inventory know the trace ID the gateway created, all the way back at the start? The trace ID and the current span ID ride along with the request, usually in the HTTP headers. The standard for this is W3C trace context, a header called trace parent that carries the trace ID and the parent's span ID. Each service reads that header, opens its own child span under it, and writes a new header for the next service. That handoff at every boundary is what stitches the journey into one. You'll also run into other formats, Zipkin's B3 headers for one. Same idea, trace parent is the one everyone's settling on. Take every span with that trace ID, lay them on a timeline, and you get a waterfall. Now you can see where the time went. The payment span is 2 seconds, but inside it, the call to the fraud check service takes 1.9 of those 2 seconds. Payment was never the problem, it was waiting on something slow the whole time. No log and no metric on their own could have told you that. One thing worth knowing in practice, tracing every single request gets expensive at scale, so most systems sample. They keep a representative subset rather than recording everything.
There are two approaches. Head-based sampling decides at the start of a request, while tail-based sampling waits until the full trace is complete before deciding, so the exact trace you want won't always be there. So use traces when you need to see across services to find where time is being spent and where things are breaking down. There's a good reason we have 3 separate tools here instead of just one. Ideally, you'd have full detail, low cost, and full coverage, but you can't have all 3 at once, so each tool gives one up. Metrics are cheap and cover everything by dropping the detail. Logs give you full detail, but they're costly and can't see beyond a single service. Traces show you the full picture across a request, but because you have to sample, you can't keep everyone. So they're not 3 versions of the same thing. They're 3 corners of one trade-off, which is why you want all 3. But on their own, each still has a blind spot. Together, they're the full picture. And what ties them together is that same trace ID, the same checkout failure start to finish. 1. A metric alert fires. Checkout error rate is up, the symptom. Second, you jump from that metric directly to a failing trace. The two are linked by exemplars, a trace ID attached to a specific point on the metric graph. One click takes you into that request's waterfall, where you can see the failure is in the inventory span. Now you know where. 3. From that span, straight into the logs. The trace ID is on every log line, so filter on trace ID equals A1B2C3. Every log from every service for that one request in order, including the exact exception that started it, the why. You move from metric to trace to log, from symptom to location to cause. What could take 3 hours now takes 3 minutes. That's the difference between 3 separate tools and one connected picture. The change that gets you all this is small. Start with an ordinary structured log, then add 2 fields, the trace ID and span ID of the request that was running when it fired. You rarely set these by hand. Connect your logger to your tracing library once in OpenTelemetry, a logging integration, and every line written inside a request carries the IDs by itself. That one connection turns 3 separate tools into one picture you can follow, from symptom to location to cause. This is what OpenTelemetry is for, an open standard tied to no one vendor that emits all three signals and passes the context for you, so the data lines up by design, not by luck. Underneath, you'll see tools like Prometheus for metrics, Jaeger, Tempo, or Zipkin for traces, Loki or the ELK stack for logs, usually tied together in Grafana. The tools change, the roles don't. Logs, detailed events, time-stamped. The most detail at the most cost. They tell you why. Metrics, numbers over time, cheap and fast, good for dashboards and alerts, but no detail. They tell you that something's wrong. Traces, one request across every service from a trace ID and a tree of spans, carried in the headers. They tell you where. And the trace ID running through all three is what ties them into one picture. If that helped, please like, share, and subscribe. Thanks for watching, and see you in the next one.